In this video, section 12.3, we go over the dot product. So the dot product is a product between two vectors. So basically you're multiplying two vectors together. However, the result of that calculation is a scalar. So let me repeat that again. Right, so the result of the dot product of two vectors is a scalar, which is a number and not a vector. So when we do the calculation, we want to be very careful about what the result of the calculation is. Okay, so because of this result, sometimes the dot product is also called the scalar product. And we're going to see later on that the dot product is related to the angle between two vectors. Okay, so how do we calculate the dot product? So basically, the calculation is given here, right? So whether you're in 3 dimensions or 2 dimensions, basically the way the calculation goes is you multiply all the corresponding components, right? So A1 times B1, A2 times B2, A3 times B3. However, you don't write that as a vector. What you do is you add those multiplications together, and again the result of this is just a single number. And then similarly in 2 dimensions, again you just multiply the corresponding components together and then add them all up, and again the result is a number. Okay, so with the dot product defined in this way, let's take a look at example 1 to do some calculations. So in part A here, we have two-dimensional vectors, but written in the standard basis notation. So to make things a little bit easier, I'm going to convert them to the angle bracket notation, right? So the vector A is just the vector -2, comma, -7, and the vector B is just the vector 5, comma, -3. Right, so you just take the coefficients as the components of the vector. Okay, so now I want to calculate the dot product A dot B. So A dot B. So how does the calculation go? You multiply the corresponding components together. Right, so -2 times 5, but then you have to add each of those terms up, right? So plus -7 times -3. Right, so again, the result here should be a number, right? So let's do the calculation, right? So the first term is -10, and then -7 times -3 is 21, and then I have to add this together, so -10 plus 21 is equal to 11. And so we see the result of this dot product is just a single number. Okay, so now let's take a look at B. So here we have two 3-dimensional vectors, and we want to calculate their dot product. So again, just following a similar calculation as before, right? So we multiply the corresponding components together. So 5 times 4, and then we add each of those terms up. So plus 0 times 4, right? So plus 0 times 4, and then plus -2 times +8. Okay, so now we just need to do this calculation, right? So 5 times 4 is 20, and then plus 0 times 4 is 0, plus -2 times 8 is -16, and then 20 minus 16 is +4. And again, we see at the very end, we result in a single number.